Hello and welcome to our very first podcast. This is Our Creative World.
And this is just me.
So, are you ready to get into the issues today?
I certainly am. So, when I was at school, which is a long time ago now, I couldn't grasp how to do long division and long multiplication. My friend showed me how to do the long multiplication and also long division, but I still couldn't wrap my head around the long division. I'm sure there's many others out there that have got difficulties with maths and how to take it all in and remember everything, and also would benefit perhaps from somebody that would perhaps describe it in an easier way to learn, and perhaps provide little video content on how to do it in an easy way, at normal pace and at a slower pace for others that find it more difficult to grasp it all.
Okay, so you are worried about long division, right?
Yeah, long division was my main one. I mean, we can cover the long multiplication if you like, and sort of like other maths issues, because maths will sort of like take you anywhere in life, won't it? It's not just multiplication and division, it's adding, taking away, subtracting, algebra, fractions, angles, geometry,
Pythagoras theorem.
Absolutely, and angles as well. The fundamentals of maths, I think that's what we need to cover, and that will be helpful for anyone of any age, I think, because we, like I say, use maths in everyday life.
Okay, so first I will get into long multiplication, since I didn't actually cover that with you guys. So long multiplication is just doing a explanation of multiplying long big numbers. So let's say you have a 2-digit number like 27 multiplied by 370. Now, I'm not going to go into the actual working out. I'm just going to do like how you would do long multiplication. So when you long multiply, you start with your two numbers. So you put the biggest number first, which in this case would be 370 times 27. So then you draw 3 lines. If you're doing this in a book where you have lines, just do it 2 to 3 lines down. If you don't, just put a big space. You'll need to draw 3 of these, possibly 4 if you're doing 3-digit times 3-digit, and so on. So first of all, you will need to find your ones column, which will be 7, and multiply it by 370. Now you do each column first, so 7 times 0 is 0, and you do the tens column, then the hundreds column. Same with the 10 times, which would be 20, so 20 times 0, 7, and 3. And then you add them all up. Make sure to present yours in the correct columns, otherwise they might get jumbled up. So make sure to do that. So then when you add them all up, you should get your final answer, and then you can write your calculation as 27 times 370 equals whatever answer you've got. Make sure to do the inverse, which is long division, which I'll get into in a moment. Make sure to do that as your inverse. Now, an inverse is doing the opposite operation for checking your answers. Now, don't do the exact same calculation again, because you might make the exact same mistake. Again, do the inverse. So now I will get into long division. So long division is like short division. If you've ever done short division, it's you write down whatever number your starting number is, which would be 370, and then you your starting number would be the answer that you got to your long multiplication, and then you divide it by 27, or you divide it by 370. But the best option would be divide by 27. Then for the normal short division, you would do 7. Actually, you do how many 27s go into whatever number, which obviously wouldn't be because it's a single digit. Next, you go to the next digit. Let's say, for instance, it's 38. 27 would go in one time. So you write 27, or you write 1, and then cross off the numbers, and so on until you get to the final answer. Now, there may be decimals, so you'll need to, when you've got your final answer, you might need to put .00, and then on your answering, you put a dot, and then no other numbers until you figure out what they are. Now, for long division, you kind of do the same thing, but then it's a bit more complicated. So when you have the first number, when you're taking away, you no, not taking away, silly me, it is dividing. So when you are dividing the first few numbers, which in this case would be, as I said, 3 and 8, you again write 1 on the top column, and then you subtract 27 from 38, which is 11. Then you bring down the next number from not your answering column, but your number that you're dividing column, which, let's say 5, so 115. Now, you do this, you keep subtracting, do it in divide, number, subtract, divide, number, subtract, and then you'll get your answer. Again, if you do need to put decimal points, you in your normal number you put .00, and in your answering you put dot, and hopefully you'll get your answer in full context. Most of the time you will only need to put 2 decimal point columns, or you can do remainders, which is when you subtract the final number. If it's less than the number that you're dividing by, which in this case is 27, if it's 26 or below, you write remainder, which is just a little r, and then the number. So if it's 27 or more, then you just put 1 more to your answer. And I hope that clears both of those things up for you.
It does, but for me, I would like to see that done on paper, pencil and paper. So do you mind doing a couple of videos for our viewers and our listeners to show how you do that the quick way, and also do it slightly slower for somebody like myself that needs to pick it up slowly? Is that something that you could do?
Yeah, I could definitely visualize it for people of all ages and all capabilities, which in your case is you need to find things slowly, and you need to understand it slowly.
Exactly. So an explanation on the different, as you're going through it, an explanation on what you're doing, how you're doing it, and how you come to the outcome. That would be great.
Okay. Anything else you would need to learn?
Perhaps a bit later on I'd like to learn about fractions, because again I didn't grasp the full understanding of it. no, it's something that I wanted to learn when I was younger, but I just couldn't. There was a block there, and I might have been because I wasn't that interested in fractions. I was more interested in other subjects. But yeah, that would be great if you could just do an explanation and perhaps again visual, like like a little video showing fractions and how they're worked out, and then perhaps do that again, but do it slowly for people like myself that don't grasp these things very quickly.
Okay, so you want me to do fractions, though you said later on, so is there anything you want me to do currently, such as, you know, algebra, geometry, or maybe even Pythagoras theorem, if you're interested in that?
Absolutely, because I did not learn that at school at all.
So, any of those three, like, did you want me to go into Pythagoras theorem, geometry, or algebra, or anything else in that matter?
Perhaps you could sort of run through Pythagoras theorem because, like I said, this is something that I never learnt of at school. We may have, because I know it's to do with different triangles, but it may have come under a different type of subject when I was at school, and namely different. It probably was just called angles when I was at school, or triangles, or whatever. But yeah, it would be great if you could just even quickly just go over what it means.
Well, the crazy thing is, I didn't actually learn this in maths, even though it is a maths subject. I learnt this in Latin. So, basically, what Pythagoras theorem is this guy named Pythagoras created this thing that helps us understand the angles of a triangle. So, if you've ever heard a squared plus b squared equals c squared, then that's what the angles of a triangle means. Now, if you don't know what squared is, you can check later on because we're going to get into that later. So basically, quick rundown of Pythagoras theorem. So a right angle triangle, which is isosceles, out of the three different groups, which are equilateral, isosceles, and scalene. Isosceles being the right angled. So the right angle triangle has one 90-degree angle and two other different angles that when you add them both together, they become a bigger one, which is the actual third angle. So if you add the two smaller angles, you get the third angle. Hence, a squared plus b squared equals c squared. Now, when you're doing this in school, they would give you some squares. So the length of the first side, which would be the straight side, let's say 8 centimeters. You would draw a square with each of those sides being 8. Yeah. Then the diagonal side going down, which would, let's say, be 12. You would again draw a square, all of them being 12. Now, the last side, which would be the bottom side, would be, let's say, 10. 10 on all sides. Okay. Then you find out the area, which is you count up all the squares, or you multiply one side by the other. So 12 times 12 is 144. So the area of the 12 centimeter length square is 144 centimeters squared. Now, that's because you've squared a number. We'll get into that later. So once you've done that, you can put them together and it will create a right angle triangle. And same if you add the two smaller angles, you get the bigger angle. And I hope that clears that up for you.
It does, but I would like to, see it visually. So perhaps when we do a video, that could be another explanation whilst you're doing the video. Yeah, that would be great. I'm really looking forward to it.
Okay, so you want a slower rundown, a full-on guide in a visual format. So now, since I was talking about powers and squares, I'll get into that before I get into fractions, and I'll do that after. So basically, what squared numbers are is you times a number by itself. Now that's kind of it, but there are other things like when you cube a number, you times it by itself twice. So like 3 cubed would be 3 times 3 times 3. That's just simple math, kind of. But then you do have more powers, like the power of 4, which I assume would be something I don't really know. It's not really called anything except for the power of the 4. Anyway, you do have more levels to that. I'll get into one right now. It's called tetration. Now, when you power a number, it's called exponentation. If you want to learn how to say that, then just rewind to when I say that. So anyway, tetration is repeated exponentation. Now, when you write the exponents, you do a little 2 or a little 3 on the right, in the top right corner of the number. That's squaring or cubing. Any others? You can even do powers to powers, which would be an even smaller 2 or 3 on top of the small 2 or 3. So let's say 2 to the power of 2 to the power of 2. Now 2 to the power of 2 is 4, and 4 to the power of 2 is 16. So 2 to the power of 2 to the power of 2 is 16. Saying a lot. Now tetration is repeated of that. So let's say you had 9 tetrated to 9. Now that is a massive number. It's 9 powered to 9 times. So that's 9 to the power of 9. Then you take that number, take it to the power of 9, and so on. And even 3 tetrated to 3 is already almost 8 trillion, which it's massive. Because what you do is you do 3 to the power of 3 to the power of 3 times, which that's like 8 trillion. If you want to work out what 9 tetrated to 9, take your time doing it, because it will take a very, very long time for you to do it, and there's loads more. There's 10 of them, 10 levels. I'll just tell you what they're called. I don't really want to go, because I don't want to go into it, because that will take a while. First level after tetration is quadration, then pentation, then hexation, then septation, octation, nonation, and decatation. Now, there might be more, but again, if you decatate 1 to 2, you are very close to infinity already. So, wow. Does that sort out powers for you in any way?
It sounds very, very complicated, but for somebody that does it sort of like all the time in lessons or whatever, probably comes very natural. But to myself and others that might be listening or watching, might be blown away by it, saying this is mind blowing. I really don't understand what you're saying, or can't quite grasp it. So again, is that something that you could do in a video to visually show how that works out and all the different levels? Is that something that can be done, or is that something that can't be done?
Well, it is very complicated and very hard to do, but I could do a deep dive, long format video, not a short, because that would take a while. And also shorts can't be that long. So I'll do a long formatted video explaining whole the tetration, exponentation, all the other stuff, probably up to pentation, because anything after that would take years. But you did say you needed help with fractions, right?
Yeah, fractions. Obviously, I know halves and quarters, but when you go down to eighths, sixteenths, and things, I either switched off at school at that point because I wasn't interested, or I just didn't grasp it at all.
Okay, so fractions is like percentages. Now, I will explain percentages right now. So 1% is 1/100th, and 100% is 1, and 1/100th is 1%. Now that really cleared that up for you, didn't it? I'll explain it to it a bit more in depth. So 1/2 would be, let's say you had 100. 1/2 is dividing by 2. So 1/2 of 100 would be 50. 1/4 of 100, same as halving, it's just dividing by 4. You would have 25, and so on. When you get to like hundredths or thousandths, there's place value columns for them. So its place value is the order in your numbers in a very specific way. So you have thousands, which would be like 5,000 up to 9,000, like 1,000 to 9,000. Then hundreds, 100 to 900, tens, 10 to 90, ones, 1 to 9, and then tenths would be 1/10 to 9/10. No, 9/10 to 1/10. Then hundredths would be 10 100ths to 1/100th, because you can't actually have decimals with fractions because that, for some reason, it doesn't work, which I think is a bit weird, because you should really be able to have like 50.3 100ths, but then again, it would defeat the whole point of having other fractions. So it's either or. But then again, fractions are just divisions in a very sophisticated way. So let's say you had 5/60ths, it would be 60 divided by 5. Wait, no. It would be 5 divided by 60, which is already, wow. But that would come to about well, obviously it would be 5/60ths, but in actual numbers it would be round 0.08. That's very small. If you times that by 100, it would be 8. So you can kind of see how small that number is, and I hope that clears fractions up for you.
Yeah, again, I'd like to see it visually. I've seen you doing fractions before when you've done it at home, and you've done it so quickly that it's sort of like blown my mind, thinking, crikey, how can you do that so quickly when I can't even grasp how to do it myself? But yeah, if you could do that visually, again, not just for myself but other viewers or listeners, that'd be great.